The 1991 Saturn represents a new way of automotive thinking. Several years ago, Saturn began with a clean sheet of paper to design this vehicle. By combining this design approach with time-proven technologies, Saturn has been able to meet world-class standards for durability, reliability, and driver excitement, right down to every vehicle system. This insistence on quality carries over to Saturn dealership service. Saturn has built serviceability into many vehicle systems, a design approach not taken by many other automotive manufacturers. And Saturn has developed many special tools to ensure quality service each and every time.
Hello, and welcome to this training module on Saturn vehicle systems. For many of you, this will be your first look at the Saturn vehicle, and it may also be the first of several training modules for you. In this program, we'll give you an overall view of the Saturn design features and how those features relate to service. Some of the things you'll see may be familiar to you, while others will be new. This video presentation is divided into 3 units. Unit 1 will cover the body. Unit 2 will examine the chassis and electrical systems. And Unit 3 will look at the powertrain. So let's get started with the body. The 1991 Saturn is available in 2 body styles, the Saturn Coupe SC and the sedan models, SL1 and SL2. The Saturn body has several advanced design features that improve both function and serviceability. One of the most important design features is the use of composite exterior body panels. While the hood, roof, and deck lid are sheet metal, all vertical body panels are made of composite materials. The doors are a rigid composite plastic. The fenders and quarter panels are also rigid, but they're made of a slightly different composite. And for flexibility, the fascias are made of a strong but flexible composite called TPO. These composite panels have a number of advantages over sheet metal. First, there's dent resistance. They can withstand up to 4 times the force sheet metal can take without denting. Second, these panels won't corrode, so additional coatings aren't needed to protect them from road salt and moisture. And third, service and maintenance costs are lower than those for metal panels. One reason service costs are lower is the ease with which the panels can be removed and installed. Let's watch the door panel removal procedure to see just how easy it is. On a front door, you have to remove the mirror trim panel and mirror first. Then, remove the belt seal, the door handle attaching push pins, and the door handle. Next, drill out 1 plastic rivet at the rear of the door. Remove the attaching screws, and remove the door panel. In addition to panel replacement, this is also the Saturn recommended procedure to access door hardware for service or adjustment. Removal and installation of the other composite panels is just as easy as it is for the door panels, because they're all retained primarily with screws. Repairing composite panels is fairly easy too. All you need are the right materials. For the rigid composites, like quarter panels, use filler material to repair gouges, and both filler and reinforcer to repair cracks and punctures. And for flexible fascias, you only need to use a combined filler and reinforcer material. In addition to composite panels, there are a couple of other Saturn body features we should mention. For instance, Saturn cars also feature encapsulated glass on all stationary windows, including the windshield, the stationary quarter windows, and the rear window. The encapsulated glass has a composite molding permanently affixed to the edge. This replaces the separate metal or plastic molding found on most cars, improving the appearance of the glass fit. Here's another interesting feature of the Saturn body. The sunroof retracts outside of the car. This allows more headroom than most sunroof-equipped cars because the car roof doesn't have to contain a retracted sunroof. The sunroof moves to any position as long as you press the button. However, a micro switch turns off the motor when the sunroof is fully open or fully closed. Some other sunroof designs simply allow the motor to stall if the button is still held down at the end of the sunroof travel. With the micro switch, there's less wear and tear on the sunroof motor and cables. The Saturn sunroof has also been designed to eliminate one of the more common annoying sunroof problems, water leaks. This gutter and 4 drain hoses provide superior drainage. Even if a drain hose should somehow become plugged, the gutter and the other drain hoses will still prevent the water accumulation that can lead to leaking. That completes our review of the major Saturn body features. Now let's quickly recap the features we've covered. All vertical panels on Saturn cars are made of composite materials. The doors, fenders, and quarter panels are rigid, while the fascias are flexible.
These panels are more dent-resistant than sheet metal, and they're easier to service and repair, too.
Saturn cars also use encapsulated glass for all stationary glass, providing a superior fit and appearance. And finally, the Saturn Power Sunroof is a state-of-the-art design that provides more headroom and greater motor reliability. Now it's time to stop the tape and answer a few questions in your workbook.
After you've finished, start the tape again and we'll give you the correct answers. Now, here are the answers for progress review number 1. Question 1 asks you to label the major Saturn body panels as either flexible composite, rigid composite, or sheet metal. The Saturn hood, roof, and rear deck lid, items 1, 2, and 9 in your question, are all made of sheet metal. Next, the front end and bumper fascias, items 3, 4, and 8, are all made of flexible composite. And finally, the fenders and doors, items 5, 6, and 7, are all made of rigid composites. Question 2 asks how composite panels are attached to the Saturn vehicle. The answer is that these panels are attached primarily with screws, although a few plastic rivets and other attachments are also used.
For question 3, you are asked which method Saturn recommends for repairing composite panels. The correct answer is that filler material and reinforcer, if necessary, should be used to repair composite panels. Plastic welding might work, but it's a difficult technique to master. Question 4 asks you to identify the windows that use encapsulated glass. You should have identified the windshield, the back window, and the quarter windows. The door windows do not use encapsulated glass. Finally, question 5 asks you to describe how the Saturn sunroof allows more headroom than other sunroof designs. The correct answer is that the Saturn sunroof allows more headroom by retracting outside the car. For our next unit, we'll look at the chassis and electrical systems on Saturn vehicles. Let's begin with the chassis mechanical features. The standard power braking system on the 1991 Saturn features a front disc rear drum system, while vehicles with anti-lock brakes will use a 4-wheel disc system. The power steering system is a fairly typical rack and pinion type with a speed-sensitive electronic variable orifice feature. As you'll see later, this feature can vary the power steering assist depending on the driving situation. And the Saturn also features a 4-wheel independent suspension system for optimum ride and handling. By the way, when hoisting the Saturn, be sure to place your lifts at the proper frame contact points. Do not lift on the stabilizer bars or any other suspension components. Those, briefly, are the major mechanical features of the chassis. Now, let's look at the electronics that go along with these systems, specifically the anti-lock brake system and the electronic variable orifice steering system. The Delco Moraine ABS-6 anti-lock braking system has been developed specifically for Saturn, and it works differently than most anti-lock brake systems. The main difference is that this system uses a principle known as analog pressure modulation.
Instead of electrical solenoids that turn on and off to regulate brake pressure, ABS-6 adjusts brake pressure with 3 reversible motors that move the pistons back and forth. Each piston resides in a separate hydraulic path. The front wheels use 2 separate pistons, while the rear wheels use 2 pistons which are controlled by 1 motor. As a piston moves down, the displacement area of the hydraulic circuit increases, and the pressure to the controlled brake is reduced.
Now let's have a look at the whole system. The Delco Moraine ABS-6 anti-lock brake system consists of the ABS control module, the hydraulic modulator assembly, 4-wheel speed sensors, the ABS relay, and a brake switch, along with the necessary electrical wiring and pressure lines. Unlike many other ABS systems, the ABS-6 modulator does not use a pump and accumulator, but a standard vacuum booster. In many ways, the whole ABS system is simply added to the existing power brakes, so the basic brakes are still serviced the same as a non-ABS system. When diagnosing the Saturn anti-lock system, there are a couple of helpful aids you can use.
The first is a check of the brake warning lamps on the instrument cluster. The Saturn uses 2 lamps to indicate brake problems. The red brake lamp is used for problems affecting the standard braking system, while the amber ABS lamp is used to indicate problems affecting the anti-lock system. Both lamps are used in diagnostic procedures.
The second diagnostic aid is the portable diagnostic tool, which is used with the service stall system. These tools can be used to read stored fault codes in the ABS control module. Additional service technician training modules will cover these tools in more detail. Now let's move on to the electronic variable orifice, or EVO, power steering system. As we said earlier, most of the Saturn power steering system is conventional. You probably recognize everything here. The big difference is what's attached to the pump. Right here on the pump is a device called the EVO actuator. The EVO actuator consists of a solenoid which controls a normally open valve in response to pulse width modulated signals from the Powertrain Control Module, or PCM. The valve in turn controls the flow of power steering fluid to the steering gear. During low-speed maneuvers, such as parallel parking, when full power steering assist is needed, the PCM commands 0 pulse width to the solenoid. Under this condition, the valve is completely open and allows maximum fluid flow. But as the vehicle's speed increases and less steering assist is desired, the PCM sends pulse width modulated signals to the solenoid. The solenoid then begins to close the valve, reducing the fluid flow. The PCM continues to monitor EVO feedback and adjusts the pulse width signal based on vehicle inputs to obtain the necessary fluid flow. The EVO steering system, like the anti-lock brakes, will set codes if an electronic failure occurs. These codes can be retrieved quickly during diagnosis using the portable diagnostic tool with the service stall system. For complete diagnosis and service information on the ABS or EVO systems, consult the Saturn service manual. Now let's move on to an overview of the electrical systems in Saturn vehicles. We'll start with the items that affect nearly all electrical operation, the power distribution centers and body grounds. The Saturn has 2 junction blocks, one under-hood junction block which houses maxi fuses, mini fuses, and relays, and one instrument panel junction block which holds mini fuses, relays, and the flasher unit. Both junction blocks feature a layered bus plate design, so they not only hold the fuses and relays, but they also provide central connection points for major vehicle harnesses. This eliminates many of the splices and connections usually found in wiring harnesses, thus reducing service needs associated with those items. For service, it's important to note that when you install a junction block, be sure to take extreme care when installing the connector. It's possible that you could crush the pins. When splices are needed in the wiring harness, Saturn will often use a splice pack for this purpose. Splice packs are more reliable than standard splices and are easier to service. Many splice packs also provide redundant grounds for electrical systems. Next, let's briefly look at the Saturn starting and charging systems. The system is comprised of a standard maintenance-free battery located under this heat shield in the left front corner of the engine compartment, an 85-amp generator with an internal regulator located on the right side of the engine, and the starter located in the lower rear portion of the engine compartment. The starter solenoid is integral with the motor assembly and is not serviced individually. Neither the starter nor the generator are serviceable items. Both must be replaced as complete assemblies. For ease of service, the replacement generator comes with the pulley and fan already installed. On a diagnostic note, the battery, starting, and charging systems can all be tested with the ARBS tester, which can be used to perform a variety of tests in just a few minutes. The next Saturn electrical system we'll examine is the headlamp system. The Saturn Coupe SC features retractable headlamps, while the sedan SL1 and SL2 models have composite headlamps with replaceable halogen bulbs. On either model, the system circuit is different than most others you've seen. If a fuse burns out for either low-beam headlamp, the lamp will become dim and yellow, but will still glow. On the Coupe SC, the headlamp doors are controlled by the headlamp switch. In the off position, the headlamps are off and the headlamp doors are closed. While in the open position, the headlamp doors will open, but the lamps will remain off. This function is useful if you need to perform a headlamp service, such as lamp replacement or aiming. If an electrical malfunction prevents the headlamp doors from opening, a knob on each door motor can be used to manually lift the doors. A multifunction switch on the steering column controls the turn signals and high beams. This switch is not serviceable and must be replaced as a unit with the wiper control switch on the other side of the column. Now let's briefly look at the Saturn rear defogger system. One thing you'll need to know about this system is that the rear defogger relay does not have a timeout feature. This means that once the switch is turned on, the defogger will not turn off until the driver turns either the defogger switch or the ignition off. Another important feature of the Saturn rear defogger is that the rear heating element is hard-baked into the window glass. This makes the element more resistant to scratches and other damage. Now let's move over to the windshield for a brief look at the Saturn windshield wiper system. The Saturn wiper system is controlled by this lever-type switch on the right side of the steering column. The switch moves up and down to 5 possible positions. As we mentioned before, this switch and the multifunction lever on the other side are replaced as one complete assembly. If you lose low speed on most wiper systems, you lose the entire system. But on the Saturn, the high-speed switch is separate from the other wiper functions. This means that the wipers will operate in high speed even if the low-speed functions fail or the wiper control module is malfunctioning. When you perform diagnostic checks on the Saturn wiper system, the circuits of the wiper can be probed using a DVOM with a diagnostic service probe. The only way to functionally test the wiper system is with the motor and module assembly connected to the switch. And finally, on a service note, the Saturn wiper motor and module are a complete unit and must be replaced as an assembly. Next, we'll take a quick look at the Saturn instrument panel and cluster. Our only note here on the instrument panel is that the wiring under the upper portion of the Saturn instrument panel can be accessed by removing the upper trim panel. Moving to the instrument cluster, we see that the Saturn uses analog gauges. All clusters include a speedometer, tachometer, odometer, trip odometer, fuel indicator, and coolant temperature indicator. The cluster for the double overhead cam engine also features an oil pressure gauge. In addition, the cluster includes several warning and indicator lamps. The gauges on the cluster are not individually replaceable. If a gauge malfunctions, the entire cluster should be replaced. The bulbs for the warning lamps are replaceable, but require cluster removal for access. Some additional electrical systems found on Saturns include the motorized passive restraint system, the cruise control system, the power windows, which feature a driver's express down feature, and the remote power mirror, and various stereo systems.
Be sure to consult the System Description section of the Saturn Service Manual for further information on these systems and the other systems we've discussed.
Saturn recommends a variety of testing tools for diagnosing many of the electrical systems we've shown you. One of the most important tools is the digital volt-ohm meter, or DVOM. When used with the proper test leads, The DVOM can be used to check nearly all voltages, currents, and resistances on Saturn electrical systems. A 12-volt test lamp and sharp-tipped probe should never be used for such tests unless the service manual specifically states that they be used. Some testing equipment Saturn does recommend includes the ARPS tester for testing the battery, starter, alternator, and regulator, the cruise cluster tester for checking the cruise control, speedometer, and tachometer, and the Saturn parasitic load tester for identifying abnormal electrical drains on the battery. Now for our final presentation in Unit 2, let's look at the Saturn air conditioning system. The Saturn AC system uses a rotary vane compressor which can vary its displacement to meet cooling demands without cycling. The system also features a thermal expansion valve, or TXV. This component reduces the pressure and meters the volume of the refrigerant entering the evaporator, also to meet the cooling demands of the system. In addition, the Saturn features a bottom-breathing air intake system. This active air dam directs air from underneath the vehicle, up through the inlet duct and condenser. The refrigeration system works in much the same way as other systems you've seen, except the TXV and variable displacement compressor eliminate the need for clutch cycling during normal operation. The controller for the Saturn system features manual controls with electric push buttons for AC on and recirc functions. The temperature and mode levers can both be set to infinitely variable positions, allowing drivers to blend the various functions to their liking. There are several important service notes you should remember when working on the Saturn AC system. The first two involve the Saturn compressor. First, the compressor will not be serviceable on 1991 models. It must be replaced as a unit. Second, this compressor requires a special Saturn refrigerant oil. Make sure you don't use Harrison or any other refrigerant oils in this system. The thermal expansion valve is also not serviceable. Any malfunction will require replacement of the entire block assembly. In addition, be sure you check engine applications when installing a new AC condenser. The base and performance engines use different condensers. And finally, remember that the Saturn AC system should always be charged through the low side service fitting only.
Well, that wraps up the chassis and electrical segment. Before we move on to the powertrain segment, please stop the tape here and try the second progress review in your self-study guide. The first question in progress review number 2 asks you to identify how the Saturn ABS system modulates pressure to the wheels that are about to lock.
The correct answer is item number 4. The Saturn ABS system uses motor and piston assemblies in the modulator to control the pressure to the locking wheels. The system does use solenoids, but only for the purpose of bypassing the ABS system during normal braking. The second question asks you to identify one item that is added to the standard power steering system to make it an EVO steering system. The correct answer is item number 3. The EVO system uses an actuator solenoid to vary the power assist pressure based on signals from the PCM. The third review question asks you to identify the components that help reduce the number of soldered splices in the Saturn electrical system. You should have identified both the splice packs and the junction blocks. Splice packs help reduce inline soldered splices by handling the splices for several circuits at once. And junction blocks also serve this purpose by incorporating splices into bus plates. Question 4 asks you to identify the fail-safe mode for the Saturn wiper system. The correct answer is item 4. The Saturn system will operate on high speed even if the wiper control module malfunctions or low speed is lost. For the final review question, you are asked to identify the type of air conditioning refrigeration system used on the Saturn. The correct answer here is number 2. The Saturn uses a thermal expansion valve, or TXV, refrigeration system. In this, the third and final unit of this module, we'll review the design and service features of the Saturn powertrains. Let's start by identifying the available powertrain combinations. There are two types of 1.9-liter engines available on Saturn cars, and either engine can be equipped with a manual or automatic transaxle. The single overhead cam engine with throttle body injection, or TBI, is available with the 5-speed manual transaxle, code MP2, or the 4-speed automatic, code MP6. The double overhead cam engine with multi-port fuel injection, or MFI, is available with the 5-speed manual, code MP3, or the 4-speed automatic, code MP7. The reason for the different transaxle codes is that each of Saturn's 4 transaxles has specific gear ratios matched to its engine. This helps ensure that the engine and transmission will work together as a smoothly functioning powertrain unit. Also contributing to this goal are the advanced powertrain supports that help control engine vibrations. These enhanced powertrain supports include a 4-bolt transaxle to engine mounting, a stiffener bracket between the engine block and transaxle converter housing, and supporting mounts in as many as 5 locations. In addition, both the engine and automatic transmission feature full electronic control. As this diagram shows, the Powertrain Control Module, or PCM, contains both the Engine Control Module, or ECM, and the Transmission Control Module, or TCM. The ECM and TCM receive information from input devices and control engine and transmission operation through output devices. We'll talk more about the engine and transmission controls shortly. For now, though, let's take a closer look at the engine systems. As we said, Saturn offers both single overhead cam and double overhead cam engines. The single overhead cam engine features throttle body injection, or TBI. TBI uses a single fuel injector mounted in a throttle body that is attached to the intake manifold, much like a carburetor. The double overhead cam engine uses multi-port fuel injection, or MFI. MFI uses 4 fuel injectors, 1 per cylinder. The remainder of the fuel system is the same for both engines. Let's take a quick look at some of these features. Saturn uses a high-density polyethylene fuel tank. An electric fuel pump in the tank supplies fuel to the injectors. The PCM controls the pump. This unique fuel pump module adjusts its own height, keeping the pump assembly on the bottom of the tank to compensate for the minor inflation and deflation that occurs in a polyethylene tank. The fuel lines are made of nylon for corrosion resistance. You'll find them flexible and easier to work with than steel lines, but it's important not to bend them too far. If they become kinked, you must replace them immediately. In addition, all the fuel fittings except 2 are the quick disconnect type. They can be disconnected and reconnected without tools. The distributorless ignition system, or DIS, is also used on both engines. Instead of a distributor, the DIS uses a coil pack containing the ignition coils, each of which controls 2 spark plugs. A unique feature of the Saturn DIS is that, unlike other DIS systems, you can perform a coil spark test without damaging the system. The emission systems on Saturn engines, EGR and canister purge, are fairly similar to those found on other GM vehicles, but the exhaust system isn't. All of the exhaust pipes are stainless steel. For additional durability, the connection between the exhaust pipe and manifold is made by this stainless steel flex pipe. To finish up the engine systems, let's briefly review the engine controls. All of the systems we've just discussed, fuel injection, ignition, and emissions, are controlled by the ECM. The ECM bases its control commands on information from various sensors, most of which should be familiar to you. They include the crankshaft position sensor, the throttle position sensor, the coolant temperature sensor, and the oxygen sensor, among others. The ECM uses the information from these sensors to control engine operation for maximum fuel economy and performance under varying conditions. The ECM also relays much of this information to the TCM, which controls the automatic transaxle. But before we get into the transaxle controls, let's look at the design of the transaxle itself. A diagram will help us see the components inside the transaxle. The Saturn automatic transaxle uses a parallel shaft arrangement similar to that found on most manual transaxles. And instead of planetary gear sets, 4 multiple disc clutches are used to connect gears to the shafts. The unit also has a first gear sprag clutch and a sliding dog clutch for reverse speed. All major transmission functions, including shifting, line pressure, and torque converter engagement, are controlled by the TCM. The TCM receives information on transmission operation from a variety of sensors. It also receives information on engine operation from the ECM. The TCM then operates the line pressure actuator and the various clutch actuators to control the transmission operation. So now you've seen the major Saturn powertrain operating systems and some of their operating features. But we can't conclude this presentation without a word on diagnostics. In most cases, Saturn powertrain diagnosis involves the service stall system, or SSS. The service stall system can quickly retrieve stored information from the PCM. Both the ECM and TCM monitor the operation of their respective systems, setting diagnostic codes and flags when malfunctions occur. Using the service stall system with its companion portable diagnostic tool, the technician can retrieve this information to perform diagnostic procedures, identify the malfunction, and verify the repair. The service stall system is a powerful tool that will help make Saturn dealership technicians the best in the industry. But you'll learn more about that in later technician training modules. Now stop the tape here and complete your last progress review for this module.
For question 1 in review number 3, you are asked to match the Saturn engine types with their correct fuel injection systems. On the Saturn, the single overhead cam engine comes with throttle body injection, or TBI, while the double overhead cam engine comes with multi-port fuel injection, or MFI.
Question 2 asks you to identify what functions the Saturn powertrain control module controls. The answer for question 2 is that the powertrain control module, or PCM, controls fuel delivery, emissions control, ignition, and automatic transaxle operation. Manual transaxle operation is not electronically controlled, and the anti-lock brake system has its own controller. For question 3, you are asked what material the Saturn fuel lines are made of. The answer is that Saturn fuel lines are made of nylon. Remember to replace these lines if they become kinked. And question 4 asks you to identify what the Saturn exhaust pipes are made of. The correct answer is that the exhaust pipes are made of stainless steel for greater durability. Finally, question 5 asks what functions are controlled electronically on the Saturn automatic transaxle. The correct answer is that shifting, line pressure, and torque converter engagement are all controlled electronically on this transaxle.
This completes the video portion of Module 1. You may want to review the videotape before moving on to the progress review for this program.